Hi guys. Okay, so today we're going to be talking about the scientific method and really the method or procedure that scientists use to solve problems and ask questions and find some answers about our world and the things that we're seeing. So the general gist of the scientific method is that it is a series of organized problem-solving procedures that help scientists conduct experiments. So it's really a set of guidelines that scientists use to make sure they're doing their experiments properly, they're reducing their amount of variables, which we'll talk about in a little bit, and that they are actually going to prove or disprove what they are observing or what they have identified as their problem. So there are 5 main steps to the scientific method. The first step is to state the problem or ask a question. So in order to state the problem or ask a question, you have to have an observation. We use our senses to make observations to gather information about the world. You can taste something, smell something, hear it, see it, feel it. Any of our 5 senses are used to make an observation. So for example, you could make an observation that, when you inhale helium, it causes your voice to go higher, or you notice that a certain object is flammable. So those are observations you're making, and from then you can state a problem. Why does helium cause your voice to, increase in pitch? Or why is this object flammable? So through that observation, you stated a problem or asked a question. Now, next you need to gather information. You need to investigate your problem and you have to gather information. So through this, you are going to need to measure. Measuring is a key part of physical science. Now, measurement is comparing some aspect of an object with a standard unit. An example of this would be using a ruler or measuring things on a scale, or you could measure the volume of something by determining its decibels, or frequency by analyzing its wavelengths. So you need to find something that you are able to measure, because otherwise it's difficult to determine results if you don't have something tangible that you can measure. So you need to gather your information. Once you gather your information and what you'll be measuring, you can form a hypothesis. So a hypothesis is a possible solution to a problem or an educated guess. You might be familiar with it as stated as an if-then statement, or some other form of a sentence like something will affect this. Any of those forms are correct, but your hypothesis has to offer a possible solution to your observed or perceived problem. It is like an educated guess. Next, you will need to test your hypothesis. You test your hypothesis through experiments. Now, experiments are procedures carried out to prove or disprove a hypothesis. The goal of your experiment is not to prove that you're right. By proving that you're wrong is just as correct as your hypothesis was right. It provides insight and information that, okay, you might not know what is causing your perceived problem or observation, but you do know what's not causing it now. So it doesn't matter if you prove your hypothesis correct or incorrect. All that matters is that your hypothesis was either proven or disproven. That's the only goal, because you'll find out just as much information either way. And the final step is to state a conclusion. So after many experiments, and for experiments you have to repeat, repeat, repeat. If you can't repeat your experiment, it's unreliable and it's not valid. So after many experiments and observations, the hypothesis is either going to be proven or disproven. Now, in every experiment, you're going to have 3, what's the word I'm looking for? Well, any matter, you will have an independent variable, a dependent variable, and a constant. Now, your independent variable may also be known as your manipulated variable. It's the variable that you, the experimenter, are changing. You are choosing to change or adjust one factor of your experiment. Now, your dependent variable, it's a variable that is affected by the changes from your independent variable. So it's the factor being measured, and it depends on the independent variable. Sometimes it's also called the responding variable. And the last factor we have in our experiment is the constants. Now, these are the things that never change during your experiment. So, for example, if you observe or perceive that potatoes create more sprouts in their eyes when they are grown underground than when they are grown above ground, you could test your hypothesis by deciding your independent variable. So your independent variable would be something that you could change. One thing that you could do would be say, you could change the setting. You could say, I'm going to grow one potato in the light and one potato in the dark. You're not changing the potato. That will be your constant. That's not changing. But your independent variable would be the setting or where you're placing the potato, the light and the dark. Now your dependent variable would be the number of sprouts that you see as a result from the potato being placed in the light or the dark. So that's the factor that's going to be changing, is the number of sprouts that you see. Now you can measure this, which is great. You have to have something to measure in your experiment, and what you could measure is the number or percentage of sprouts on either side of the potato. So in the potato experiment, your independent variable, or the thing that you would be changing, is where the potato is grown. The dependent variable that you can measure would be the number or percentage of sprouts for each potato. And you can measure that by counting how many sprouts there are and then finding the percentage. And then your constant would be the actual potato. You need to have a constant because if you have multiple types of potatoes, like a sweet potato and a red potato, well, you don't know if it's sprouting more because it's a sweet potato or if it's because it was in the light or the dark. So you need to reduce as many variables as possible in your experiment. Let's look at another example. So David read that Fox brake pads and Best brake pads were the best on the market. He always used Napa pads and believed they performed the best. He decided to test all 3 pads and determine which was the best. David used the same car for each set of pads. He drove 25 miles per hour and applied the brakes at the same point on the track. David then measured how many feet the car took to stop after the brakes were applied. So his hypothesis was that the Napa pads, if he used the Napa pads, then his car would stop faster. So he is measuring the effects of the brake pads on the stopping point of the car. Now his constant in his experiment he's using the same car, he's stopping at the same point on the track, and he's driving at the same speed. So again, let's look at that one more time. His hypothesis is that the Napa pads will perform the best. So if he uses the Napa pads on his car, he will stop sooner on the track, which he can then measure in feet. So he's measuring the effect of the Napa pads on the stopping point of his car, which he can measure in feet. So he can measure how fast the car is stopping. Now his 3 constants are, he's using the same car, the car is traveling at the same speed, and he's stopping at the same point on the track. So he's applying his brakes at the same point. Again, just as a review, scientific method, the 5 main steps are to ask a question, construct a hypothesis, test your hypothesis by doing an experiment, and in your experiment you'll have an independent variable, a dependent variable, and a control. And you need to analyze your data and draw a conclusion and You need to test your experiment multiple times to make sure it can be reliable and proven or disproven.